Alright, so last time we were talking about what's called the Roche limit. Let's take a look at that. Alright, so again, this was this guy Roche discovered. Well, he didn't discover this. He mathematically predicted that such a distance would exist, and basically it would prevent any large moons from forming inside of this region, which is traditionally called the Roche limit. So you don't see really large moons inside of this this location, and it depends on the mass and the size of the particular planet that we're talking about. So all the rings are within the Roche limit. So basically, if a moon, the material that formed the moons try to form, they would, there would be that particular moon would be crushed due to tidal forces. But by the way, this is also explaining, and I think I mentioned this when I was talking about Jupiter. All the gas giants also have rings. Saturn's is, of course, the one that's the most obvious, that can be seen from the Earth. There's methods that you can see the rings from the other ones, the other gas giants from the Earth, but it really has to do with starlight behind, passing behind the planet and passing through the rings, and we observe the starlight varying through the rings and kind of twinkling, if you will. All right. The rings are actually quite complex, and this is a nice drawing to show you how large they are. This is a to scale model. It shows the Earth, which is roughly 8,000 miles from one end to the other, the diameter of the Earth. Roughly, it's that size. The Earth could easily fit inside of this. All right. There's actually some structure that the Voyager spacecraft back in the 1980s, the Voyager 1 and Voyager 2 spacecraft showed. This is a very famous moon, very small moon called Enceladus. We'll have a lot more to say about that shortly. It's right outside of the E ring, which is actually one of the strangest of all the rings of Saturn. Let's see. So this is, you can see these, they called them spokes or spikes within the rings. We think that this is just dust. It's dust material. It doesn't stay forever. This pattern will disappear and then reappear. So something, there's got to be some location where that dust is coming from, and we'll see today. The rings also occur in resonances. Just like the moon is our moon. The Earth's moon is in resonance. That is, one side of our moon always faces the Earth because it's tidally locked. Some of the moons are, basically they'll orbit around Saturn, or really any of the gas giants. Maybe in what they call 3-2 resonances, so that they'll spin about their own axis 3 times for every 2 times that they orbit their host planet. We also found in the 1980s, using the Voyager spacecraft, what are called shepherd moons. These moons are really tiny moons that basically keep some of the rings in place. One goes in front, is further in front in its orbit than the other moon, and basically any material in between will remain stable in the ring formation. Let's see, are they showing this? Usually there's nice pictures of the shepherd moons. All right. Oh, there it is right here. Okay, so there's a shepherd moon. And these are really, really tiny moons, right? Remember, they can't really exist, being really large. All right. Some of the moons will actually are kind of like, if you twirled some string, and the string got kinks in it. We actually observe that with some of these moons. Some of the rings. All right. Let's see. We don't think the rings are as old as the planets. As old as 4.5 billion years. They seem to be relatively. Well, not young or anything like that, but we think that maybe the rings have been around for several million years, maybe hundreds of millions of years, but certainly not billions of years. All right, there's a lot of evidence that shows that. Let's see. So now let's turn to the moons of Saturn. Let me start with Titan. Okay, so Titan is the largest moon in the Saturn system. It's actually just slightly smaller than Ganymede, which is, of course, the biggest moon in the solar system. The moon of Ganymede being, of course, the moon of one of the moons of Jupiter. Anyhow, Titan we knew for a long, long time that Titan was different in the fact that it has an atmosphere, and actually a pretty thick atmosphere. Most moons that we observe do not have atmospheres. They're too small. And in fact, the moon of the moon Titan, the atmosphere, we think, is very similar to the Earth's atmosphere when it was a very young planet. It is composed mostly of nitrogen, and all right. So that's we'll talk about how we explored Titan using the Cassini spacecraft, and it's there was also another spacecraft that was actually piggybacking on top of the Cassini spacecraft called Huygens, the Huygens probe, which actually landed on Titan. All right, so we'll talk about a little bit about that. We have video of that. It's really pretty amazing. You can find that video on YouTube if you ever look. All right. Anyhow, here are 6 what are called medium-sized moons: Mimas, Enceladus, and these are just the names of them. A lot of the moons, for some reason, got names from Shakespearean plays. Just to let you know, that's not that's important or anything. All right, so Titan has a relatively thick atmosphere. In fact, thicker than Earth's. It is composed mostly of nitrogen. There is even some argon, which, of course, we find on the Earth as well. The Earth's atmosphere has a little bit of argon in it. And we actually, because we knew that this was an interesting location when the Cassini spacecraft was launched, as I said before, it had this small probe that was launched not right away, but when it got there and everything was aligned, it was called the Huygens probe, and it landed. It landed on the surface of Titan and took pictures. Which, let's see, did we have the pictures? Let's see. There's the atmosphere is particularly complex. More complex than we originally thought. There's complex chemistry going on, and here are as the Huygens spacecraft was descending, it actually recorded the sound of the, as it passed through the air of Titan. It's kind of cool if you ever get a chance to watch that on YouTube. All right, so here are the pictures when it landed. So there's some rocks. Another thing that we found is, we really couldn't see the surface from the Earth, or even from the Cassini spacecraft, the surface of Titan I'm talking about, very well, because of the atmosphere is particularly thick. And so one of the things that we found, of course, besides the rocks, is there were actually lakes, like liquid lakes on the surface of Titan. Now, these lakes were not water lakes. They were actually made of methane. So these were giant lakes of, well, not giant, but large, relatively large lakes of methane. So for using the Cassini and the Huygens spacecraft, this is what we understand about the interior of Titan. We think that it might even have a liquid, liquid water underneath the crust. All right, and of course, it has a solid surface, as you just saw the pictures of the rocks. So that's pretty significant. Yeah. All right, so that's just more about Cassini. And Cassini was in orbit for many years. All right, this is just to give you a sense of the size of these medium-sized moons, these so-called medium-sized moons. Notice Mimas has this interesting feature that there's crater. Sometimes Mimas is jokingly called the Death Star moon because it kind of looks like the Death Star from the Star Wars movies. Anyhow, that's kind of besides the point. I mentioned that they are tidally locked. Now here, okay, so besides Titan, probably the most interesting moon of Saturn was Enceladus. And this is a tiny moon, very, very tiny, and we saw, the Cassini spacecraft first observed geysers, saltwater geysers coming from the South Pole of Enceladus. And Enceladus is very, very smooth, relatively smooth, very few craters, of course, we now understand the reason for this. It has to do with the orbit of Enceladus, where the moon is being tidally squeezed as it gets closer and further from in its orbit around Saturn, and that's what's causing these. Sorry, I didn't mean this. These geysers. All right, so we think that there's a liquid ocean underneath the surface, and hopefully in the future there'll be missions to explore the interior of Enceladus. Here are two moons that are actually swap orbits. These are rather tiny moons, but kind of an interesting feature. Let me mention what's called Lagrangian points. I don't think we've talked about these before. Anytime you have one object orbiting another, there are what are called Lagrangian points. These are stable points where if an object ends up in those points, basically the gravity between the host planet here and the moon cancels out, and two of the Lagrange points are 60 degrees in front and behind the orbit of this particular moon. All right, very good. So that is the end of this. This is just the summary. You can read that at will. All right, this is everything we talked about, and good, very nice.